All right, the first one. The integral of x e to the x dx. I'm going to recopy it down here. So notice that we have a product, x e to the x. I'm just going to show you, do not write this down, why we can't just use a u substitution. So if you were to use a u substitution, what would you pick for u? E to the x? Okay. So what's du dx? So that means dx, oh, I'm sorry, is, I almost picked up a real eraser, is du over e to the x. Well, the problem with that is, if you plug all this back in, you called e to the x u, and your dx is du over e to the x. Does anything cancels? No. And actually, no matter what you pick for u, even if you try to double substitution, you're still going to have an x left over. So regular u substitution will not work here. We have to try something more powerful. We need to try something that's the Vicodin of integration. No Vicodin for you. Okay. So that's where we pick this integration by parts. So there's two things you have to pick, and you can write this in your notes. You have to pick a u and a dv. So we basically make a little chart here. You want to pick your u as something that's easy to differentiate. You want to pick your u as something that's easy to differentiate. You want to pick your dv as something that's easy to integrate. So u is something easy to differentiate, and at the same time, dv is something that's easy to integrate. I'm just going to tell you what to do for this example, and then we'll open it up for suggestions for the following examples. Our u we're going to pick is just x, because x is very easy to differentiate. And our dv, we're going to take the remaining part of the integrand, e to the x dx. So we have to fill the remaining portions, and the remaining portion here would be saying what du is, meaning what is the derivative of x with respect to x? 1 dx. Yeah. So in other words, du is the same thing as dx. And on the other side, we're going to integrate both sides. This guy right here is technically the integral of 1 dv. What's the antiderivative of 1 with respect to v? Well, 1 is the same thing as v to the 0, yes? So if you did your power rule, you'd have 1 over 0 plus 1, v to the 0 plus 1. What does that clean up as? 1v. So the integral of the integral of 1 dv is just v. We're going to be doing that part a lot. And how about the antiderivative of e to the x with respect to x? What is the antiderivative of e to the x? E to the x. It's its own derivative. So let's do a recap. So we picked a u and a dv. U is something that's easy to differentiate. V is something that's easy to integrate. Don't forget about your dx and dv as necessary. So once this chart is set up, then we can use this formula. So the integral of x dx, x e to the x dx, where we called this part u and we called this part dv. So notice that's the left-hand side. The integral of u dv is equal to u times v. What is u according to our chart? X. What is v? E to the x minus the integral of v. What is v? E to the x du. And what's du? 1 dx, or just dx. So that's how that formula is used. We had something on the form, the integral of u dv, and we rewrote it using integration by parts. The x e to the x is outside of the integral. We don't do anything with it. So I'm just going to copy that down. And to finish this off, what is the antiderivative of e to the x? E to the x. And since this is an indefinite integral, what do we need at the end? Plus c. Oh, that's a cute c. Yes, it is. So that's the answer. X e to the x minus x plus c. It doesn't look it, but if you differentiated that and cleaned it up, you would get x e to the x.